Okay, welcome back to Inside Astronomy episode 2. In this episode we're going to look at cleaning our stack, getting our data ready for stacking in PixInsight. We're now going to look at how we need to clean our data to make sure that it's in the best possible condition for stacking in PixInsight. Now luckily I've managed to gather some data myself. It wasn't a great night and you'll see that coming up shortly. It was one of those nights where possibly you would have said don't bother tonight because the weather's not going to be great. However, when you live in Northern Europe, in the Netherlands where I do, and I'm sure many other people around the world have the same problem, if you wait for the perfect night, you'll be waiting an awful long time before you image any data. So, in the hope that I would get at least some good data, some good color data for my Galaxy NGC 7331, which is now ongoing for more than a month, I tried to do some imaging. The night was showing as overcast with some high-level cloud, but with clear spells in between. Therefore, there was a realistic chance of capturing some reasonable data. There was also a very good chance of catching some, well, not so stellar data. But for episode 2, cleaning your image data stack, I guess that all works out fine, because now we can use that data to go through and see how we can clean it. Now, one of the tools that I like to use first is a very simple tool, or at least it comes across as a very simple tool. Blink is the first tool in PixInsight that you'll come across that allows you to set a period whereby you can go through your data and allow it to play in a continuous loop. And therefore, you can highlight whether or not you want to throw out or discard frames which are too cloudy, or maybe have a very bad satellite strike, or even a plane hit across maybe even the center of your object. Blink is the ideal tool to go through your stack as the first step. But Blink dates back to 1905 when the Zeiss company actually made a Blink comparator. And astronomers have been using Blink comparators for, well, the best part of the 20th century to track changes in the night sky. And one of the most famous discoveries in astronomy is the discovery made at the Lowell Observatory by Clyde Tombaugh when he discovered Pluto. He discovered Pluto using a Blink comparator. So when you use Blink, think back to those astronomers, those famous astronomers that you admire from the 21st century, sitting in front of those plates with their Blink comparator, checking for any changes in the night sky which may reveal a new planet such as Pluto at the time, or comets, or even meteors moving across the night sky. So now we will go into PixInsight and we'll open the Blink tool. So let's go to Processes, be one of the first ones at the top, Blink. There it is. As Blink opens, it's a very simple tool. You can see it has an empty space here for the file, so we click the folder icon at the bottom. We can go to my red images. I just select one of those images and I'm going to go Control A to select all the images. I'm just going to scroll down, make sure they're all selected. As you can see, all my red frames are now selected. If I place Open, PixInsight will load the data into the Blink tool. We can move that to one side. You can see the image there of the galaxy, and you can see in the frame, in the corner, left corner there, the galaxy as well. So now what we can do is we can set a time here. 0.05 seconds is a bit too fast for me. I like 0.2 seconds when I'm blinking my data. It just allows me, I'm a little bit older now, to react, to be able to stop this when I see a frame that I don't want. Now, already we can see an issue when we run Blink, and this is quite common, to be honest with you. Some of the frames are not stretched properly, and you can see that now. What we can do, we stop this, and we come up here to this histogram icon at the top, and we say Apply Automatic Histogram to all images. And we let that apply, and now it'll stretch all the images equally, and we can run again. And now it looks a lot better. Now you can see, if you look very carefully, you can actually see some satellite hits. You can also see the galaxy dimming, and you can see, oh, that big hit there. Let's let this run one more time and see if I can stop it. A few small hits, which I'm not too concerned about. There's the meridian flip. And here we go. There we go. Oh, sorry, pause. Go 3 back, click back, back. You see this frame, that's a waste of time. So dim because of the clouds coming over. But where is the one with the hit? Just a bit even further back. There we go. So that frame there, this frame obviously needs to be discarded. That looks like not a satellite hit. That's actually a hit by a plane. Those 2 large broad tracks going through the image. Of course, with the wonders of statistics and PixInsight, it will remove or attempt to remove this type of artifact, but that's a frame that will be discarded or thrown away. And then we step forward, we can see here again, you can actually see the degrading of the image till it becomes so dim. Yeah, it's pointless. It's pointless adding that data to your image stack. You can check it here, go back up to the frame. Here now you can see on the left hand side, there we go, that one can be unchecked. So essentially what you're going to do is go through your data, play through your data, wait to see, there we go, again, you saw again, we can go back with the arrows here at the top. Again, look at that, look at the left hand side of the image, how the clouds are coming in there from the left, dimming the galaxy. So again, you would say, okay, being critical, that has to go, that frame has to go, you know, and also the frame before it. Then you come into some good data again, play. The one strike there, this fine strike is a satellite strike. I wouldn't be too concerned about that. Again, because with the magic of statistics, PixInsight will be able to remove that. And also it's a single, very fine strike, so it will have minimal impact on the image as well. So I would leave that in the stack. Let's just go through. There's a meridian flip. It's not the greatest of data in the world. There we go. Again, now we're hitting clouds. Go backtrack. So those 2 there are also basically being removed. And now, there we go, we've cleaned, we've used Blink in our first attempt to clean our data. But you see these frames here, if you look at the frames before there, I don't like that one either. You can see clearly that the transparency is significantly lower between those 2. This one is significantly worse. I would drop that one out as well. Okay, one of the annoying things about Blink is that the checked boxes do not indicate you've selected a file. So you've got to go over them with command click or shift click, as you can see now, as I'm highlighting these files with orange. And then basically, I like to move these to a new folder. I call that the folder red approved. And then these red files, these subframes, better to say, are then moved into the folder, the approved folder for at least the red channel. And of course we do that then for the blue and green as well. So now we just hit here, the folder icon, click, move to red approved, open, and there you go. Those files are now moved over, ready to continue the process. Yeah, there they are. If we look at files in the red channel, 14 items, and files in the red approved channel, 45 items. These are the files in that red channel that were not approved, not selected by us. So let's just double check that. What we can do here is we can close all these images, and we say okay, let's now load up the images that were left over in our red folder that are not approved. And you can see already these are the ones that we decided were not to be included in the stack because they simply weren't good enough. And again, you can see the problem with the stretch, but just for completeness, I'll stretch that there again. And now you can see this is what was rejected using Blink. And I think this is a very important step. I like to be in control of the data that gets stacked. If you want to produce high quality astrophotography images, you really need to take control of the stack itself and clean it. Some people rely too much, I believe, on weighted batch processing. It is a great tool, and we'll cover that in the next episode. Now, when you've been outside with your telescope, especially running Nina, when I first came to Nina some years ago now, one of the things I like about Nina is the ability or the snapshot it gives you as it's capturing frames. It shows you the change in focus position or in full width half max as it changes over the night, and it also shows you a little it also graphs the star count, the number of stars being detected as you're imaging. And you can see this graph changing. Here you can see it now. This is one of my image runs, and you can see Nina showing you the data set, the graph, how the conditions are changing over time. The number of stars obviously reduce when the transparency becomes poorer, or even you get clouds or high level clouds coming through. So you can see the star count goes down. And of course, as the weather changes and the telescope acclimatizes, now I don't have that problem with the observatory, but you will when you're setting up your equipment and tearing down each night. As your equipment acclimatizes, it will potentially contract, which will change the focus point of your telescope. And over time, you can tell Nina, okay, if the focus drifts by more than 5 or 10%, then please refocus the image. And when you have an automatic focuser, that will of course happen. But you can see these changes happening in Nina, and you can also see these changes happening in your data set. So now let's move to the next tool, which is a more sophisticated tool. It's actually at the end of the chain, but it's called Subframe Selector. Subframe Selector is the next tool that we're going to apply to the stack of approved data for the red channel that we've already looked at. So let's open Subframe Selector and see what it can do for us. So you get 3 windows with Subframe Selector. The main window, a kind of play window where you can put expressions, and a graphical window there on the left. So now let's add the files. So we're not going to go for these red, we're going to go to the red approved, which we've blinked. So we've already removed some of the most offending data using Blink from our stack, and now we're going to put these in there. At the top here you can say output frames, star detection preview. What we want to do is we want to set it to measure subframes. For now we simply want to measure. I will speed this along so you don't have to sit through this process. Of course, that's the magic of video editing. Okay, so now we have our results. So let's first go over the table on the left hand side, Subframe Selector measurements. You can see here it makes a lot of measurements for us. You've got the file name, it's giving a weight, your point spread function signal weight is there, but essentially you have eccentricity, the number of stars, full width half max, noise ratio, flux, measurement of the flux and the scale. But what you've got to do if you want to make sure that this is correct, especially with the point spread function, you need to come back to your measurement box. Now I simply click this forward, basically because, well, I don't really do much with this. The measurement here is not that important to me. What I'm looking at is the full width half max. Whether that's correct, i.e. the pixel scale, or it's incorrect, doesn't really change the size of the stars. If you want to make it correct, then you're going to need to change the number of arc seconds per pixel here. So let me just quickly show you how to do that for your particular telescope. I've prepared a slide on this, so I will go to that slide now and let's review. So just a little bit of maths here for us, not too much. The issue with most of the maths is the fact that if I take you back to your school days, is this thing called radians. Most of these calculations are in radians, and most of you are more familiar with degrees, just like I am. Basically, the difference between radians and degrees comes back to pi. Pi is, of course, 3.1415, but 2 pi brings it to 6 point something or other. And if you divide 360 degrees by 2 pi, you get 1 radian is equal to 57.2 or 0.3 degrees. Why is that important to us? Because that gives us a magical number, which you will have seen probably a lot, especially when you look at different astronomical sources on the internet. You'll see this number coming up all the time, 206265. arc seconds, and basically that's 1 radian, the 57.29, times by 3,600. The 3,600 comes from 60 minutes in 1 degree and 60 seconds in 1 minute. So 60 times 60 is 36, 3,600 arc seconds in 1 radian. Now, to calculate how big a pixel is for you, how many arc seconds per pixel, the field of view of your telescope is a simple formula. It's the 2 times the arctan. Arctan is a simple inverse tan on your calculator. Maybe what I can do is I can try to get this up, but there, the arctan is the little brown symbol, so it's shift tan on this Casio calculator. So your pixel divided by 2 times the focal length of your telescope, and that's in radians, of course. Now, to simplify this formula, and it can be simplified because normally this focal length would be in meters, so we'll move it to millimeters, which is easier for everybody. But that means that your pixel size needs to be adjusted. So my camera is 3.8 micrometers. Now 3.8 micrometers would normally mean that would come out to 3.8 times 10 to the minus 6. Now, because I'm in millimeters, I can increase by a factor of 1,000, so that 3.8 micrometers now comes out in this formula to 0.0038. That number needs to go over 2 times the focal length in millimeters, and once you have that answer, i.e. 2 times the inverse tan of that answer, if you then times it by the 206,265, you will have your size in arc seconds per pixel. Mine for the RC is stupidly small, especially for the Netherlands. 0.356. There's no chance on God's green earth that I'm ever getting that resolution with my RC. I'll be lucky to get as low as 2 arc seconds, maybe 3 arc seconds here in the Netherlands. There's certainly no way that I'm getting to that level. I would need to be in the Atacama Desert or in Gran Canaria up the mountain somewhere to get even close to that level. There's just no chance. But that's the lowest I can bring the RC down with the astrophysics reducer, so that's what I'm working with. Anyway, this is how you would calculate for yourself how big your pixels are in arc seconds. Once you have that, if you're really motivated to do so, you can put that value back into Subframe Selector. So let's do that now. Now that we've done the maths and I've explained to you how we get to the answer that we've got to, let's put the actual arc seconds per pixel back into Subframe Selector and tell it to measure again, and then we'll have the correct full width half max data in the table. So let's do that. Okay, so now we're back in Subframe Selector, and you can see here that I put the arc seconds per pixel correctly in this window. 0.3565 arc seconds per pixel. The camera gain was set for my 1600mm Pro at Unity, so one electron should be a photon, so Effectively, that's just 1, so that's fine. So now the table should be correct. Okay, now we have this correctly set up. Let's go to the left-hand side and let's set up the graph and make sure this is correct. Now, what you see here is it's already set on PSF signal weight. I don't particularly like that myself, and I like to use full width half max. Maybe I'm a little bit old-fashioned. Yes, you can choose whatever you want to choose here from the available data, from the available measurements made on your subframes to sort your stack to clean it. But what we can see here now immediately is that the best frame is here, this one. Now, of course, if I click on it, it's looking like I want to remove it, but this one here, taken on the 12th of November, 1023, looks to be the best frame. Now, we'd have to check that visually, but right now that is showing to be the sharpest frame in my stack. Now, when you look at the graph, what I want you to realize, you see two bands, two grey areas here. Now, the darker grey area is 1 sigma. The lighter grey area is 2 sigma. And that's basically sigma based on a normal distribution, a Gaussian distribution, or the bell curve, however you want to call it. So what does that mean? So each side of that median is the sigma, 1 sigma. So effectively, the dark grey bar already covers more than 68% of your data. So 68% of your data is falling into this dark grey bar zone. The light grey zone is the 2nd sigma, but either side it would be 4 sigma. So that now covers more than 95% of your data. Now clearly we can already see here that I have some frames which are way out of specification, outside of that 95%. So these 3 frames, these 4 frames, 5 maybe, are really looking very poor. Now, if I want to eliminate them, I can simply click on them, as you've seen me do right now, and eliminate those frames, and again make another approved folder, and for the final time move the approved subframes to the new approved folder, and that would mean my stack is now clean, ready for further processing. Now, there's a much better way to do this, and I just want to show you another metric before we move on. So let's unclick these and let me show you what I mean. So all the data's back in. If I now go here, there's another one I like, and the reason I like it is the number of stars. Well, look at this. So the number of stars in most of the frames, nearly 68% of the frames, the number of stars are at least 220 to 280. In 4 sigma, the low end and the high end, that covers just under 200 stars to over 300 stars. Now you can already see some of the frames I started clicking away here with the circles around them have a very low star count. A low star count means that potentially, well, clouds came through or the transparency changed, and those subframes were effectively ruined by that change in transparency. So potentially now I should eliminate those frames as well. What if I want to use both metrics to clean my stack at the same time? Okay, so what if there's a better way? A way we can capture the files all in one go, and perhaps even use 2 parameters at the same time to eliminate bad files from our stack? Well, there is. If we come over to this frame on the right hand side, Subframe Selector expression, let's now type in a expression here. So I'm going to put full width half max less than 2, and then I'm going to hit the little play symbol here, and you can see immediately that has eliminated those files that I selected manually, the files that are outside the subframes that are outside the full width half max of 2. Now, what if I want to also use star count? What if I want to say that I want a minimum star count of at least 200? Well, you can do that. You can put ampersand twice and stars. Let's just check on the data here. Stars. So you have to use the same name as the top here in the columns. And let's say stars greater than 200. And we can play that. Of course, it hasn't worked. I had an error message there. You can see what I did. Stars with an S, greater than 200. Now you can see, well, we've had 2 groups of subframes eliminated. Now, whatever you want to do here, you can potentially do that. Whatever metric you choose to measure your data to eliminate those poor subframes, you can chain them together with or ands and eliminate them. So I like, because again I'm influenced by Nina when I moved over that little indicator, and again I'll put a little video out there of an imaging session showing that the measurement of the star count and the I think it's half lux radius in Nina. I don't know why they have to name things differently, but anyway, it's the full width half max, how focused the stars are. You can see it changing over time. But another one could be, another interesting one to look at could be eccentricity. How oval or misshapen are my stars as are being captured? So you could add that as a metric as well. Now, I would tend to be a little bit more careful about adding things like eccentricity, because you've already seen in episode 1 how powerful Blur Exterminator is. I would not be too critical or too fast to set let's say, a strict eccentricity, because I think you can probably correct those stars with the Blur Exterminator later on in the processing of your image. Okay, so I've decided to use those 2 metrics, full width half max and the star count, to clean up my stack. So what now? Now it becomes very simple. Now we come to the top of the Subframe Selector tool. This is, let's consider this as the command area, and we say output subframes. So where are we going to output these subframes? Well, just for the hell of it, I have made a new folder. I've got now red, approved. So if you remember, the first selection was with Blink. This second selection is now with Subframe Selector. And now I would consider this data to be cleaned and ready for stacking. But there was one final thing we need to do. So I'm clicking what I think is the best frame, or what Subframe Selector is showing me to be the best frame. Now, it's highlighted at the top here, it shows it as eliminated. But what I want to do is say, okay, this seems to be the sharpest frame that I have. And what I'm trying to check is, yes, it seems to fall within my star count as well. So 261, if you remember, is on the high end, because if I go to stars, 300 is the max, just under 300 is max, and it's already there. So that's not doing too bad at all. If we go back to full width half max, okay, so let's open this frame. This is red number 1023, taken on the 12th of November. So now, all I'm going to do now is open that frame and take a visual look at it, because what I would like to do, and this is another point for episode 3, and that is that the weighted batch processing. Normally people allow it to select the best frame itself, and then if you consider that your whole stack is going to be stacked against that one frame, well, you're asking for trouble. So what I like to do is to find through this process which is the best frame myself. Let's say this is being highlighted now by Subframe Selector as the best frame. Visually check it, and then I will use that frame. I will set it myself in the weighted batch processing. I will set this then as my reference frame for the weighted batch processing tool. So I'm sure that the best possible frame is being used to stack against. It's just another tip that I recommend that you do. It's easy to find this frame, and now let's go and check it, which one it is. Well, you can see that those stars do look good. I wouldn't say this is a great frame by anyone's stretch of the imagination, but I will show you again the conditions under which this was taken. But those stars, for a single sub of red, are really nice and round. Yeah, I think I can accept that as my reference frame for stacking the red channel against. We ended up with how many frames? So in the red approved from the blink, we had 45. By the time we went through with Subframe Selector, we now only have 36 of those frames have made it to the final stack for the red channel. And we will do the same again for the green and for the blue channel as well. So I hope you find this useful, and we will go through the other tools as we continue to process this image, and I will show you them in turn. I didn't intend this video to be 30 minutes plus, but I thank you for watching this far. I hope you find this useful as we continue this PixInsight series, and I will say bye for now.